All right, so this is 1.2. So it says solve for x where x is a real number. So your goal is to get x by itself. So we have the square root of x plus 4 plus 12 equals 4. So your goal is to move everything away from x. What I like to tell my kids is basically you're doing PEMDAS, but backwards. And if you remember, PEMDAS is parentheses, exponents, multiplication or division, adding or subtracting. So if we're going backwards because we're trying to get x by itself, then we're going to work with the adding and subtracting first. So if you notice, we have a plus 12 here. The opposite of plus 12 is negative 12. Whatever you do to one side, you do to the other. The reason why we didn't do this positive 4 is because it's underneath the square root. This 12 is all by itself, so that's why we're working with that first. 4 minus 12 is going to give me negative 8. I'm left with that x plus 4. Now, we look to see if there is any, going back to PEMDAS, we're looking to see if there's any multiplication or division. We don't have that. Next, we go to the exponent. Well, I know that when I square root something, I want to get rid of the square root. I do the opposite, which is to square it. Whatever you do to one side, you must do to the other side. So, x plus 4 equals negative 8 times negative 8 is the same as saying negative 8 squared. So that's going to give me 64. I still need x by itself, so I'm going to have to subtract that 4 over to get x equals 60. Okay, moving on to number 2. The same thing. We want the x's by themselves. So what we're going to do is square both of the radicals. And the reason why I am squaring both of the radicals, oops, sorry guys. The reason why I'm squaring both of the radicals is because I want to get rid of those square roots. So right now I have the square root of 5x plus 12, rule number 2, equals the square root of 7x plus 16. If we want to get rid of the square root, we square both sides. And that's going to cancel out that square root. So that leaves me with 5x plus 12 equals 7x plus 16. I want x by itself, so I'm going to move my variables, my constants, I'm going to move my variables from the right side to the left side. I can only move this 7x over to this 5x because they are like terms. What I mean by like terms is they both have x's. If I was to put it with this 12, it wouldn't work because this does not have an x. 5x minus 7x is going to give me negative 2x. I didn't do anything to that 12, so I'm just going to bring it down. That negative 7x cancels out. I'm left with 16. I still need x by itself. So I'm going to move the constant. A constant is the number all by itself. The number that's all by itself right now is 12 and 16. So I'm going to move my constants from the left to the right. Remember, we moved our variables from the right to the left. Now we're going to go from the left to the right. It's positive 12. The opposite of positive 12 is negative 12. That cancels out. I'm left with negative 2x equals 16 minus 12, which is 4. If you feel like the video is going too fast, pause it. At any point, pause it. I want x by itself. That negative 2 and that x is multiplying. The opposite of multiplying is to divide. 4 divided by negative 2 is going to give me x equals negative 2. Okay, let's go on to number 3. using the quadratic formula. So if you remember from class, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c. And remember, this is a formula that you probably learned in algebra back in the day. However, this is just one of those I probably would add to my note card, since you guys do get to use a note card on your final. So this would be a formula that I would add to my note card, because you're not going to memorize all that. So use the resource that you have. That's my formula. All I'm doing is coming over here to the side and listing out my A, my B, and my C. And the reason why I know what my A, B, and C is because this is the standard form for quadratic equations. Ax squared plus bx plus c. So that means that A is 6. That's why we got 6. That means that B is negative 3. That's how we got negative 3. That means C is negative 1. That's how we got negative 1. So now all I'm going to do is take that into the formula. So I'm going to rewrite the formula. X equals negative B. Oh, what's B? B is negative 3. Plus or minus the square root of B squared. Oh, what's B again? Negative 3 squared minus 4 times A. Oh, what's A? A is 6 times C. What's C? C is negative 1. Oh, don't forget to divide by 2 times A, and A is 6. Now you can type that all into your calculator. My only thing is, make sure you put the parentheses there so you can get the correct answer, and make sure you type it exactly how you see it. So now I'm just going to simplify this. A negative times a negative is going to give me a positive 3. I just brought down that plus or minus. Square root. Negative 3 squared is 9. Minus 4 times 6 times negative 1. That's going to get me positive 24. All over 12. Because 6 times 2 is 12. Okay? I'm just going to come over here to the side because I'm running out of space. 3 plus or minus the square root of 9 plus 24. It's going to give me 33 all over 12. And since the square root of 33 does not simplify, I can leave it as is. And how I know it doesn't simplify, because when I come over here and make the tree, I just get 3 and 11. And that's it. So I'm going to leave it as the square root of 33. So when you write your answer, I'm running out of space. Let me see. Let's do this. So when you write your final answer, oh goodness, life is happening. You can write it as 3 plus square root of 33 over 12, and 3 minus square root of 33 over 12. Or they might even ask you to do it like this, which I just broke it up. Square root of 33. Running out of space, I do apologize, over 12. Okay. All right, I'm going to erase that so we can look at number 4. All right, number 4. we are looking at absolute value. Remember, absolute value is the distance from 0. So the rule is, now we got this space, rule is if the absolute value A equals the absolute value of B, which in this case, A does equal B, then A equals B or A equals negative B. Okay? So that means we're going to do 2 separate problems. I'm going to erase this so we can get to it, so we can have some space. My rule is true, so I can drop the absolute values. 5u minus 13 equals 5u minus 7. Not 17, sorry, just 7. And also remember, A equals B, so that also means A equals negative B. Equals negative B, which is 5u minus 7. Okay. Alright, so we want u by itself. Take your variable from the right, move it to the left. Oh, what do you notice? They both canceled out, left you with negative 13 equals negative 7. Does negative 13 equal negative 7? No, it does not. This is a false statement. Okay? I have a negative here, so I need to distribute that into the parentheses. 5u minus 13 equals negative 5u plus 7, because negative times negative 7 is positive 7. Okay, move that 5u over, but since it's negative, we're now going to make it positive 5u. 5u plus 5u is 10u. I'm just bringing down that negative 13 and that 7 because we didn't do anything to it. I want to move my constant to the other side by doing the opposite. 10u equals 7 plus 13, which is 20. I still need u by itself. Where that 10 and that u is multiplying right now. So the opposite of multiplying is to divide both sides by 10, and u equals 2. Okay, come back for the next video for number 5.